Hi everyone, this is Mr. Ko here. I hope everyone is safe and sound. Okay, now I'll just try to explain some questions in paper 1 based on some of your feedback on the questions that you find a little bit hard. And the first question that you have picked is question 11. So I have copied down a little bit of the question here. Okay, so ignoring the beautiful handwriting, just take a look at the important things in the question. Now, the information says that there are 2 flower beds, and one bed is a circle radius r, and the other is a square side x. And the total length of the wire is 40. So to solve this question, just know that this is a maximum minimum word problem. So generally, of course, I draw a simple picture. But the most important thing we always remember is that maximum minimum word problem, you start from the given information, right? Always remember that. And the given information is that the perimeter is 40. So the perimeter is just the circumference of circle 2 pi r and the square 4x. Total is 40. So making x the subject of the formula, you get x is 10 minus half pi r. So now later you want to prove that the area is a certain formula. So let's go to the area. And you can see that the area is just pi r squared plus x squared. And you substitute in the x is 10 minus half pi r from the first part. Do some expansion and combination. And you will be able to simplify until you get exactly what is shown there. Okay. Now the next part is getting A stationary. So of course you see the word stationary, you know you have to differentiate and set it to 0 and solve for the radius. The last part, I'll do until the second last part because I think the last part is easy enough. So after that, you find the x, you substitute in the radius that you found previously, which is 20 over 4 plus pi. Do some simple simplification and you can see very clearly that the x value is twice the radius. Thank you. Now I move on to question 4. Now question 4 is a trigo question, but it doesn't look like your typical type of trigo questions, you know, where you use trigo identities like sine squared theta plus cos squared theta equals to 1, etc. And it looks to you like this is like an AMaths type question. And of course that's true. It is like an AMaths type question if you solve just like an AMaths type question. So always remember this. Usually whatever your first instinct is always true. And then when you look at this diagram, of course the first thing you see very clearly is this right angle triangle. And then the moment you see a right angle triangle, the only thing you think about is a Pythagoras theorem and your simple trigo ratios, you know, your tuakaso. And really that's all we need to solve this question. Okay, so how am I going to do the first part? Question is looking for RS. So you see that there are 2 right angle triangles in this question, PQR and RQS. So I'm going to make use of these 2 right angle triangles to solve the question. So let's start with PQR. Now PQR, if you sine the 60 is the opposite hypotenuse, RQ over X. And RQ is just X sine 60, and sine 60 of course everybody knows is root 3 over 2. And then on the same triangle you apply cosine 60. You get cosine 60 is PQ over X, and PQ is X cos 60, and that's half X. And SQ is 1/3 of PQ. Take a look, SQ is 1/3 of PQ because the PS to SQ is 2:1 that's given by the question. So SQ is just 1/6 X. Then triangle RSQ, the small right angle triangle, we use Pythagoras theorem. And then after that you get RS is that proven. Okay, so very simple Pythagoras theorem tuakaso. And even the second part is done in the same way. Now you just need to focus on the right triangle, triangle RSQ. and sine 30 minus y. Okay, because y 30 minus y, if you look at the triangle, this y, the whole thing is 30 degrees. Angle R is 30, so angle SRQ is 30 minus y. So sine 30 minus y is the opposite hypotenuse on this triangle RSQ. Do a little bit of rationalization. You get 1 over 2 root 7, but you do a little bit of rationalization of roots of surds, you get root 7 over 14, which is what is part of your answer. So your 30 minus y is just sine inverse of root 7 over 14, and y is 30 degrees minus sine inverse of root 7 over 14. Okay, so this is the way to solve this question. Of course, the hint being that why do I take 30 minus y is because I can see very clearly the answer is 30 degrees. So no matter what, I'll just use the difference there. So that's the link. Thank you. Hello everyone. The last question I'm going to explain for Holiness and High Paper 1 is 8B. Some of you say you have problems with this question. So I assume it's part B, because part A is a standard question. So basically, for this type of question, actually is nothing. You just substitute in the point. Y is x plus, this is the x value and the y value. Just substitute into the equation. Okay, to do the most natural thing. Okay, and that you get 27 is a times 2.25 power n. That's equation 1. Similarly, you also given 4, 64. Sub that into the equation as well. So 64 is the y value, 4 is the x value. Just put it in and get 64 is a 4 to the power n. So now the key to this question, of course, is in order to solve for a and n, the fastest way to get rid of one of the unknowns is actually to do divide. This is the key step in the whole question. Just divide equation 2 over 1, so that when you divide, the a cancels, and then you get you can take out the base. You check that you make sure that the base is exactly the same. Okay, so both left and right can be expressed as in terms of 4 to the power 3 to a certain power. Equate the powers and you solve for n. So that's the technique for this question, is to divide the equation. So remember, it's not always like lower sec where you solve simultaneous, you always plus or minus. This one you divide. Just remember, any method that helps you get rid of one variable, the fastest way, just do it. Thank you.